Now here's an example. Now, as you can see, here's an object. Okay, so this is the name of the object, but it's an instance of a user interface, so like a window, or like a user interface. So could be a window, could be a form. Okay. Now we need to have a hotel chain, an object of hotel chain. So this is supposed to be a reservation event or reservation use case. So we need an object of hotel chain. Okay, we may give it a name. Now here, make reservation. This is supposed to be, when you need to translate that into code, it's supposed to be a method defined inside that class that could be called from that object. So you can call a chain dot make reservation. Okay, so that's the general meaning of it. Now this activation or the execution frame starts with the call, the beginning of call, and supposed to end with the return. But because there might be no return, so the return arrow was omitted. Okay. Now, in order to make the reservation, you will need an object of hotel, and the message that you need to send to that object is make reservation again. So there is another definition of a make reservation function inside the hotel. Okay, so definitely it is part of the make reservation for the chain, but it would have different implementation that's specific to hotel. Okay, so when you write this make reservation function, inside of it, you need to make a call to the method called make reservation that is part of the hotel object. Okay. Now inside here, we can say that there should be a loop. So how do we indicate a loop in the sequence diagram? You can create this as this context frame and say that this is a loop. Okay. Now the message can be sent. So when you are inside the object, you can call a method from the same object, right? So that's the self message. Okay. So inside the make reservation of the hotel, you need to call a function called available that would check whether a room is available. Okay. So we see it starts to appear as a function when you are sending parameters here. Okay, and they're supposed to be they could be returned, but all the return errors were omitted here just to reduce the cost. Okay. Now, what if we have alternating conditions or a case switch cases, like set conditions? So you can have also alternatives, okay, context. So if there's a room, you would do this. Usually there would be a line that separates between one alternative and the other. Okay, but here it's just one check. If there's a room, we do that. It's just an if without an else. If there is an else, you can just split this alternative context and add the else in the lower part. Okay, so what is happening here? So what's happening here? We want to create a new object. So you see, the objects that appear at the beginning here, all of them must be created at the beginning of the case, or the use case, or the beginning of the event or the action. Okay? Not all objects would be created at that. So when you start execution of a script, not all objects that you have, not all classes that you have would have objects instantiated out of them, right? So some of them needed at the beginning. Some of them are not going to be created until later, or even not created at all. In that case, here we have an alternative. So we have a condition based on which we may create an object of reservation. Okay, so this is not just a message call like this. This is just an instantiation, a call for the construction. Okay. So this is the create message. And then when you create this object, you need to create another object of type confirmation. All right, so this is the example of objects that needed to be created later on in the interaction, not at the beginning. Okay. Now, if you happen to need to stop, or perhaps for a window, for a user interface window, you may need to say that this window needs to be closed. Okay, or at least need to disappear. All right. So this is the sequence diagram. And eventually we're going to have an example of a diagram and its implementation. But let's at least learn about the diagrams in general. Any questions about the sequence diagram? Okay. Now the second type of a very popular behavioral diagram is the activity diagram. So in the activity diagram, you may recognize some of these symbols. Do you recognize this? It's not called activity diagram, otherwise it is called, there's another popular name. But you may recognize these symbols. I think flowchart. Yeah, flowchart is another popular name. It's very similar to the activity diagram. Okay, so what symbols do we have here? So obviously this is the start symbol and this is the end symbol. So this is the beginning and this is the end. Now the arrow indicates a direction and the sequence between activities. Okay, the decision or the diamond would indicate the branching and the ending of the branch. So we have multiple decision like options to choose from, and then when the choice is over and then you get to join at the end, you can also use that diamond symbol. Okay. Now the activity itself, obviously this is the main component here. It's just the activity or the action or the step, depending on what stage you are using to describe the diagram. It can be just steps in using a system or steps in the code itself, like lines of code. All right. Also, depending on the system you are creating, you can have parallel execution or parallel paths or things that, so you have different paths that can be going in parallel, so what's called concurrently. At the same time, multiple actions going in the same time. So in that case, you would use this fork symbol. So this is the branching. So this was the previous step, and then it branches into or more, could be more. Okay. And then when you get to join them, after the branching ends and all of them going back to one path, you can use this join symbol. So it's just the same bar, but just these are the parallel paths. Now they are joining into one. Okay. So let's see. Here's an example of a activity diagram. So this is the beginning and this is the end. Okay. Now there is a task of receiving an order or activity of receiving order. So this is a kind of a high level. You can use the same syntax to describe lines of code as well, but this is more of a high level. And then there is concurrent passes. So some set of actions that can happen in parallel. So while we are filling the order and doing all these, we can also send the invoice and receive the payment. Okay, so if we go this fast and fill order, and then there is a branching based on a question. So sometimes you can put the question inside the diamond, or sometimes you just write the determining factor on the line itself. So you can say rush order or otherwise. So if it's rush order, there's an activity that happened for it. Otherwise, there's something else that happened for it. And then eventually you want to join back into one task. So if you have if-else statement, so if-else, and then after the else ends, everything, regardless of whether you enter the if block or the else block, it continues in one path, right? So that's pretty much what happened here, the joining. And then also after this end, there is also a join. This join is just joining the forking that happened here. And then we may have other activities in the join path or not. In this example, we just ended here. Okay. So this is the activity diagram. One of the popular diagrams that used to describe behavior in software engineering. Okay. Any questions about behavior diagram?